Hey everyone, today we'll be going over LeetCode problem 198, House Robber. This is another problem off the Blind 75 list, which is a list of problems commonly asked during technical interviews. In this problem, we are given an integer array called nums, and this array represents the amount of money in different houses. We want to imagine that we are a robber, and we want to rob these houses in a way that will generate the most amount of money. However, we must keep in mind that we cannot rob two adjacent houses. After robbing these houses, we want to return the maximum amount of money possible that we can rob from these houses without robbing two adjacent houses. So we have this nums array in this example, which is an array of 4 houses with $1, $2, $3, and $1 respectively in it. And we see we have an output of 4. I have redrawn this example here to the right, and let's think about how we can solve it. The brute force would be to use decision trees in order to take into consideration every possible path of robbing these houses. Now we know we cannot rob two adjacent houses, so if we rob house with $1 at position 0, we know we cannot rob this second house with $2. Furthermore, if we rob this house with $2, we know we cannot rob both this house with $1 and this house with $3 because they're both neighbors of this house with $2. So let's start drawing out these decision trees. We know we have the first case where we could rob the house at index 0, which has $1. And if we go and rob that, we know that afterwards we can either rob the house with $3 or the last house in the array with $1. And of course, we know that we'd want to rob the $1 house plus the $3 house because we generate more money in this way, because that makes a profit of 4. However, we also have the second case, where we start off by robbing the house with $2 and skip the first house instead. In that case, we cannot rob the house with $1 nor the house with $3, but we can rob this last house with $1. So we would add this $1 to our decision tree, and we would get a total of 3. So at the end, we would still know that our max would be from this first path of robbing $1 plus $3 to get 4. Now the time complexity of these decision trees would be around 2 to the n, because during each process, we are considering whether or not to rob the house. However, let's think if we can actually solve this in a more efficient manner. In fact, if we look at this problem, we can actually keep dividing it into sub-problems and use dynamic programming in order to solve it in a linear time complexity. Let's try to divide this problem into smaller sub-problems. As we said, we had 2 choices. We can rob this house with $1, and in that case, we cannot rob the house with $2. However, we could then continue on to rob the remainder of the houses and find the max from robbing those remainder of the houses. Or in a second case, we can skip this house with $1, the first house, and instead find the max from robbing from the second house on. Keeping this in mind, we can divide our problem into subproblems. So we know that robbing the house could generate a max, which depends on 2 cases. We can either rob the house at index 0, plus find the max of robbing from the house at index 2 to the last house at index n. And we can compare the amount of money we generate through this path compared to instead finding the max from robbing from the house at index 1 to the end, therefore skipping the house at index 0. The case which is highlighted in red would be this first case over here, robbing the house at index 0 plus finding the max between robbing the house at index 2 to the end. And the second case highlighted in green is this one where we find the max of robbing from the house at index 1 to the end. Now, both of these cases over here can then go and be divided into smaller subproblems. And because of this, we can use dynamic programming. So let's take into consideration our specific array. We would go along our array starting from the beginning, and at each point, write down what is the max amount of money we can rob up until that point. So we know, for example, when we start off with the first index, the index 0, we can rob $1 if we rob that house. So our max up until this point would be $1, because it is better to rob this house rather than not robbing this house. When we get to the second house, we know that our case would be either to rob the house with $1, which preceded it, or rob this house with $2. And so we know that at this point we would want to rob this house with $2, because we're not looking at anything that comes after this point. When we get to this third house with $3, we know that we could either decide to rob it or not rob it. Now, however, if we do not rob it, then we can take into consideration these $2 we generated in the past. And instead, if we decide to rob these $3, we could add it to the $1 that we found 2 positions ago, which is not adjacent to the 3. Therefore, we would rather do this second case, where we have the $1 plus these $3 to make 4. Finally, we take into consideration how much we can rob until the end. Now, we know that if we rob this house with $1, we can add it to the $2 that we generated 2 positions ago, and that would make a sum of 3. Or we could decide not to rob this house, and instead take the preceding value, which is 4. We know 4 is greatest, so of course we would want to take that 4 as our max value up until this point. And this is how our algorithm will work, in order to find that our result will be 4. Now, as we see, in going along this array, we only need 3 values. We need the maximum value generated 2 positions ago, the preceding value, and the current value that we are currently finding. Therefore, we could just take 3 pointers, which we can call rob1, rob2, and cur, and move these pointers along to find our result. And this will make our algorithm constant in space complexity, along with being linear in time complexity. We're going to start off our code by solving 2 of the edge cases that we can have. If we only have one number in our nums array, so if the length of nums is equal to 1, then we just want to return whatever value is in this array, because that's the only house that we could rob. If we have 2 numbers in our array, then we just want to rob the house with a greater value, because we know that we cannot rob both since they're both adjacent. So we're going to return the max between the house at index 0 and the house at index 1. Then we want to create our 3 pointers. We said that we would have a rob1 pointer, rob2, and a current pointer. So we're going to set rob1 and rob2 initially equal to 0, as well as our current. And we're going to iterate through our array, starting from index 0 to the end. We know that the maximum amount of money that we can rob up until this current point is going to be the maximum between robbing this house and adding how much we could rob up until 2 positions ago, or skipping this current house and instead taking the maximum amount we can rob up until the preceding house, because we know we cannot rob 2 adjacent houses. So if we take rob2 as our value, we cannot rob our current house. Then we just need to move our pointers along. So we're going to make rob1 equal to rob2 equal to our current pointer. And our current pointer will be found in the next iteration. When we're done with the for loop, we could just return either rob2 or cur. And let's make sure this runs. And we see that it works efficiently. Thank you so much for watching this video. If you enjoyed it, please like it and subscribe to my channel. I'll see you on the next one.